Why do two bulbs consume different power with the same current? We know that resistance always limits the current in the circuit. Let's split one bulb into two with equal resistances. Now we have two bulbs and each affects the current. Change the resistance of the bulbs to see how the current changes. Let's look at the water analogy for series connection. Analogous to the circuit, water flows through two narrowed sections of a hose. Change the resistances and EMF to see how the water flow changes. Both resistances limit the current, so they can be combined into a total resistance. Let's denote the total resistance using indices of individual elements. Now we can simply calculate the total resistance. We already know how to calculate such a circuit using Ohm's law. Let's find the current in this circuit. Current can be easily determined by Ohm's law. If necessary, the sum can be substituted for the total resistance. Let's take a closer look at the voltages. First, consider the case when resistances are equal. What do you think? This voltage is absolutely correct. In this case, the voltage is equal to half of the source's EMF. With equal resistances, EMF is always equally divided. What will happen if the resistances are different? Similarly, we determine the voltage on the second bulb. Another fact: the sum of the voltages on the bulbs is always equal to EMF. Later, we will name this fact Kirchhoff's second law. Which bulb do you think has more power? Not quite. Right now, we will look together at how to calculate power. The same current flows through both bulbs. This means the bulbs will differ only in voltage. We can easily calculate the power using the formula we know. Calculate the power of the second bulb. Similarly, we can also calculate the power given by an ideal battery. In the next lesson, we'll understand what an ideal battery is. Notice an interesting fact. The sum of the bulb's powers is equal to the battery's power. Be sure to conduct more experiments with series connection. We've taken another significant step in mastering electricity. A gift is available for you.